Alright, Mr. Claxton's Algebra 1 or Algebra 2 CP or even Fundamentals class. What we're going to explore today is the inverse property of multiplication. I'm going to define it and then use it in several examples. The inverse property of multiplication could also be called the multiplicative inverse property. Multiplicative inverse is just a fancy way of saying reciprocal. Reciprocal. Excuse my poor handwriting. And we would probably all define the reciprocal of a number as just the flipped fraction version of that. So any value multiplied by its reciprocal will equal 1. So let's go ahead and take and use or identify a couple examples, right? Example 1, you might say, what value can I multiply by 1/3 to get 1? So what value, when multiplied by 1/3, is equal to that special value 1, which we call the identity element of multiplication? Well, you might be thinking, oh, Mr. Claxton, come on, that's 3/1. It can get even as crazy as, get a little crazier here real quick, -47 over 17. What value can I multiply by -47 over 17 to get 1? You're thinking it. I'll be writing it here shortly. If you don't know the answer yet, think harder. What value can we multiply? Maybe look back to the example before. If you were thinking 17 over -47, and you were 100% correct. One very important note to make is that this negative can be down there. That negative could be up with the -17. That negative could be out in front. I typically don't like it out in front because it gets too confusing out there. So we're going to go ahead and drop it back down with the -47. Alright, so we would define the red version as the multiplicative inverse of the black version, and the black version as the multiplicative inverse of the red. You know, it might be better to also explore some additive inverses, just so you can get a feel for what an inverse is. An additive inverse would be any number that we could add to another number to get the identity element of addition. What's the identity element of addition? 0. So what value can I add to 3 to get 0? -3. And we could take something as crazy as, alright, I'm going to start off with -pi. And we get -pi. I'm going to add the additive inverse of -pi. What's the additive inverse of -pi? It must equal 0. You're thinking, alright, Mr. Claxton, it's pi. I get it. Pi tastes good. Pi's hungry. Or pi makes me hungry, rather. Alright, so multiplicative inverse, once again, several examples. So if I were to ask you, what is the multiplicative inverse of 1/7? The multiplicative inverse would be 7/1. Notice how I did not make that negative. It's just the reciprocal of it. Looking back on a couple problems that you might be required to do, we'll go and look at a few examples here of problems that you might be required to do. Looking all the way back to something like 38, or, well, slide 38 rather. Write the reciprocal of each number. The one that often confuses students is number 34. In number 34, again, we have that pesky negative. And that pesky negative can be right there in the middle. That pesky negative can be up top. That pesky negative could be in the denominator. I typically like to throw it up top. So that's the first thing I do is I take that negative to either the numerator or denominator. I don't like it being in between like it is there. So the reciprocal of negative 1/4, the reciprocal, notice how I don't put an equal sign. I should put something like recip, is 4 over negative 1. Now 4 over negative 1 can be rewritten simply as negative 4. Alright, so multiplicative inverses really aren't that tough. It's the same thing as a reciprocal. 0 does not have a reciprocal, so if you were asked to find the reciprocal of 0, that does not exist because you are not allowed to divide by 0. I know that you know that. Looking at something like a mixed number, in order to find the reciprocal of a mixed number, the first thing you need to do is convert to an improper fraction. Okay, so you want to convert. We converted 1/2 to 3/2. So what is the reciprocal of 3/2? The reciprocal of 3/2 is going to be 2 over 3, which, so the reciprocal 1/2 is 2/3. Alright, I hope that helps you out. If you were continuing on or into the review assignment, which is going to be worth many points. Okay, many points. That review assignment is going to be worth many points. You could check your work against what I'm viewing right now on the screen. You feel free to pause at any time in order to get the answer or see what the work looks like. I've shown many different ways that you can show the work here, except for on number 6. And on number 6, I think many of you know you could just represent that as 15 minus 7. That is another way to represent it. Looking at 7 through 14, you can check the answers. Feel free to pause it at any time to check the answers. And then 15 all the way through 22. You did have to do the first 22 last night. Continuing on, there is a problem that some of you might struggle with, and it might be the decimal problems. You can always go back to the old school method of subtraction for those. For something like 24, though, there's really no need to make it more complicated than it is. That's the same as negative 5 7/7600 plus, notice how I use keep, change. So I kept the negative 5 7/7600. I changed the order to addition, and then I changed the value to negative 1 9/10. And if you're a person who would skip right to the opposite of, and then just take and add 5 7/7600 plus 1 9/10, then that would be okay if you would skip down to here for your work. Looking ahead, though, there are a couple problems I'm concerned about. The couple problems that I'm very concerned about are ones that look like 29 and 30. Now, in 29 and 30, there are two different ways to complete this. You can convert to improper form first, or you can work with the mixed numbers, either one. If we work with the mixed numbers, we do need to find a common denominator, but the first thing I'm going to do is I'm going to rewrite 29, because I see I'm subtracting a negative, so I'm just going to add a positive. That to me is a lot easier. Then I'm going to take care of those fractions. Because I'm adding now, it makes it a lot easier. I know that the common denominator of 4/5 and 1/2 is going to be 10. In order to get 10, I need to multiply just that fraction by 2 over 2. New value of 7 8/10. Add to that 1. Oh, and I need to multiply 1/2 hopefully you're thinking 5 over 5. So 1 and 5/10. And you probably could have completed that without even 1/2 is the same as 5/10. Now I can split them apart. I can split them apart. Take the integer values, 7 plus 1. Okay, and I would always put addition in between, and then 8/10 plus 5/10. Now this is where things get a little interesting. I have to know how to interpret the fraction that I get. Because you know that 8 plus 5 is going to give you 13. So because of that, you know that you're going to need to add some to this 8 right here. That 8 is going to be increased because I would now have 13/10. 13/10 does convert to 1 and 3/10. So working on down the line here, and I know many of you are going to combine steps. So 8 plus 1 and 3/10. It's going to give us an answer of 9 and 3/10. Okay, so 9 and 3/10 would be our answer there. Alright, in the next example, you could subtract both of those. You would need to find a common denominator first. I am not going to make you multiply. For those of you who remember maybe last year, whenever you do multiply fractions, you do just multiply straight across. There does not need to be a common denominator. The unique thing about this is we can use something called cross-canceling. Cross-canceling to cancel out the 3. Okay, that's one group of 3 and one group of 3. For a final answer of 2/15. There are many, many different ways to get an answer for that one. And again, I'm not going to include this on the quiz. I might make it bonus, but many of us know how to do it. Really, 3 times 1 is 3. 8 times 2, 16. 3/16. Now, I can't simplify anymore. They do not share any common denominator, or excuse me, they do not share any factors. Excuse me. With 7 and 4/5 times -1 and 1/2, I would want to convert these to improper fractions first by multiplying 7 times 5. That's 7 groups of fifths. 7 groups of fifths is 35, plus 4 more is going to give me 39/5. That's going to be multiplied by this negative value, 2 times 1 plus 1, and I know that it's going to be negative. That answer is going to be negative. 2 times 1, I don't even consider the negative. 2 times 1 plus 1 is 3. I take the negative of that. So multiply that by 3/2, and I would multiply 39 times -3 and 5 times 2. You do the same for 34 over here. Just moving along, absolute value is the distance from 0 to a number line. Something to make a note of is whenever there's a negative outside the absolute value, okay, that is going to make, that will give you a negative answer, right, when it's outside, because you take the absolute value of -3, which is 3, but we have to account for that negative on the outside. So my answer there would be -3. There are the operations to complete down below. If you want to, you can grab the key and check yourself. And I know it's been about 14 minutes. You do have the rest of the period to work on this assignment if you have not been doing so already. Thank you very much for paying attention, and happy calculating, everyone.